Hello guys, thanks for watching my video. Today I like to do one theorem in theory of equation. Okay, I just name it theorem 2. Okay, it states that if a polynomial f of x has a 0 alpha plus I beta, it has also the 0 alpha minus I beta, meaning a polynomial f of x have a 0 alpha plus I beta, then it also have alpha minus I beta as 0 of this polynomial. So let's try to prove this. Now let f of x be a polynomial with real coefficient. Okay, the coefficient of this polynomial will be a real number, and let alpha plus I beta be a 0 of the polynomial, meaning in our given equation theorem it states that alpha plus I beta is already at 0, right? We have to prove that alpha minus I beta is 0. So therefore let f of x be divided by x minus alpha plus I beta times x minus alpha minus I beta, and let the quotient be qx and the remainder of first degree be r1x plus r2, where r1 and r2 are real number. Okay, meaning in our Euclid algorithm, okay, we have that dividend is equal to divisor times quotient plus remainder, right? So our remainder is in first degree is r1x plus r2, and our quotient will be q of x, and our divisor will be this, and our dividend will be f of x, right? We have to divide them. Now then f of x is equal to, according to this, okay, x minus alpha plus I beta, x minus alpha minus I beta times q of x plus r1x plus r2. So it follows this one, but we know that alpha plus I beta is a 0 of f of x, meaning it is already given here. So meaning if you substitute the value of x as alpha plus I beta, then you get f of alpha plus I beta is 0, because this alpha plus I beta is a 0 of this polynomial f of x. That's why it is 0. Now putting x equal to alpha plus I beta in equation 1 here, we have that f of alpha plus I beta is equal to, so x is alpha plus I beta minus alpha plus I beta, and alpha plus I beta minus alpha minus I beta times q of alpha plus I beta, right, plus r1 of alpha plus I beta plus r2. Just substitute the value of x. Now therefore, since this is 0 here, right, 0 equal to, so these two will be 0 again. 0 times these things, and this will be 0, right, plus r1 alpha plus I beta plus r2. Now we have to follow with this one. So from this equation, if you see that, now taking out real part and imaginary part, okay, separate them. So r1 alpha plus r2 plus I of r1 beta, where I is imaginary number, right? This I is nothing but square root of -1. So this is 0 from this, so equation 2. Now equating the real and imaginary part. Now since this is 0, so our real part will be 0 and imaginary part is also 0. This can be written as 0 plus 0i, right? So it will be alpha r1 alpha plus r2 is 0, then is the real part, and alpha r1 beta is 0. But beta cannot be 0, okay? But this beta cannot be, alpha and beta is cannot be 0, okay? So therefore, otherwise the 0 alpha plus I beta will be wholly real, right? If this beta is 0, then this, the 0 of the polynomial alpha plus I beta will be only a real number only, right? So there will be no imaginary number. Because of that, hence we have that r1 is 0 and then R2 is also 0, right? If this is 0, then R2 is 0. Therefore, we have that R1 and R2 is 0. Therefore, putting the value of R1 and R2 in equation 1, then is equation 1 is here. In this, we have already found the value of R1 and R2 and substitute here. Then you'll get what? F of x is equal to x minus alpha plus I beta, x minus alpha minus I beta into qx, right? Because R1 and R2 is 0, so 0 plus 0 it will be 0. The remaining part will be, only this part will be remain, right? Now, this will be vanished, okay? Again, this equation will be vanished, meaning it will be equal to 0 when x is alpha minus I beta. First, we have already done that when x is equal to, where? Okay, when x is equal to alpha plus I beta, this polynomial is 0. And similarly, so if you substitute the value of x is equal to alpha minus I beta, then this will be 0, meaning this whole thing will be 0. Therefore, meaning f of alpha minus I beta is 0, meaning alpha minus I beta is also a 0 of this polynomial f of x. Hence, alpha minus I beta and alpha plus I beta are 0 of f of x. Okay, this will be just for this theorem. That's it.